Thumbs up.
Yep, we are live.
All right, so we're live. Welcome to the July Central Florida Astronomical Society meeting, everybody. We have an exciting program for you tonight, and we're very thankful that you're still joining us each month for our little virtual get-togethers. A couple of things to talk about. We have some upcoming events, CFAS-only webinars that are coming up this month. On July 11th at 6 o'clock, Derek is going to be giving a talk on planetary imaging. And on July the 18th at 7 o'clock, I'm going to be giving a webinar on nightscape photography. And this is only for CFAS members. We've got our main speaker tonight is David Eicher, who's going to talk about his new book on galaxies. And David is also the chief editor of Astronomy magazine. And so if you haven't heard of him, yeah, Frank's got his book. We can't do author signings, right? That's one of the downsides to the virtual things. And we have our standard fare of mini programs to follow. And a big announcement, we will have an August meeting this year. We often skip the August meeting because the college is shut down. And at the last board meeting, I all but begged the board. I said, hey, why don't we just take a month off? But everybody wanted to have a meeting in August, so we will have an August meeting this year. So kind of cool. Maybe it's like a leap year sort of thing, or maybe only during the apocalypse. The Astronomy Club meets, every month instead of taking a month off. One thing I want to talk about real quick, just a sort of quasi-personal note, and also to relate it to everyone else. Most of you follow me, on Facebook. A lot of you are friends on Facebook, or it's heard through the thing. Yes, I did get robbed on a trip to Colorado, and yes, they did clean me out. They did not take all of my astronomy stuff, so it's not like the end of the world, but they broke into the car, and they got a Paramount and a 6-inch refractor and all my Naglers and my camera lenses. And to prevent lots and lots of questions, yes, we did actually call the police. We thought that would be a good idea. And yes, I do have insurance, which will cover, some of it to a good deal. But what I want to talk about too is, a lot of us pile our astronomy gear in our cars and we go places. And and I'm not defending myself as much as I want to let everybody else know. I did do everything right. I do 3 or 4 star parties a year, for software bisques. So, this is not my first radio, and I usually have even more gear in an SUV. And, it's all packed away. It's all on the bottom. It's covered up with clothes and blankets and junk food. Car does not look like it has anything in it. Just a car without estate plates, in the wrong place at the wrong time. They broke the window. They completely cleaned out the car. They had a van or something. So this wasn't like somebody heard that I had a whole bunch of expensive astronomy gear. It was just a random, they said it was a meth ring probably in Kansas City. And my wife, the night before, she's like, park under the light. So we even parked under a light, which just means they can see what they're doing and they can move faster. Try to bring stuff with you that you could bring into the hotel room. If it takes an hour to load the car, it's just not practical. I'm not really sure how this is going to change my habits moving forward. I'm not sure I want to do events anymore that are more than a day's drive, or maybe I should get an RV. I don't know, but just some tips for when you're traveling with astronomy gear or with a lot of cameras. The world is not in a good place right now, and there does seem to be, because like I said, I've done this for over a decade, usually with even more stuff in a locked vehicle, nicely concealed and that sort of thing. So anyway, with that out of the way, I'm going to let Tricia talk, because Tricia is our vice president and brings in our speakers. I'm going to let Tricia introduce Dave Eicher. I'm going to stop sharing my screen. Stop share.
Thank you, Richard.
Take it away.
Sorry to hear about that. That kind of sets a downer tone. So we will, I guess, talk about good things from here on out. So tonight we have a special guest. We have David Eicher. And so let me tell you a little bit about David before I let him take over. Give me 1 second here. My screen just...
Should I get out of screen sharing? Sorry about that.
Yeah, that's okay.
Okay.
Okay, here we go. So, David is one of the most widely recognized astronomy enthusiasts in the world. He has been with Astronomy magazine for 36 years, beginning as an assistant editor and working through associate, senior, and managing positions. He has been the magazine's chief editor since 2002. Dave has widely spoken to amateur astronomy groups, logged many hundreds of hours at the eyepiece, and written 15 books on astronomy. Among them are Galaxies, Inside, The Universe of Star Cities, Mission Moon 3D, and The New Cosmos, answering astronomy's big questions. Tonight, we're going to have the link to his new book, Galaxies, and we have the link actually to a signed copy for $30, and that's going to be a hardcover option. Dave is also president of the Astronomy Foundation, the telescope industry and astronomy outreach group, from 2011 to 2017. He lives in, I'm going to butcher this, Waukesha? Wow.
Waukesha, believe it or not.
Waukesha. Okay, that sounds easy. Waukesha Township, Wisconsin, near Big Bend, with his wife, Linda, a school teacher, and his son, Chris, who is a journalist and videographer. So with that, I'm going to hand it over to you, David. So again, thank you so very much for joining us tonight.
Well, thank you very much for having me. It's a real pleasure. I think as far as we can tell here, Waukesha in Wisconsin, it's an Indian word that means cold and cloudy, I think, after being an astronomer living here for 37 years. But anyway, that's a different story. I did want to talk a little bit tonight with you about galaxies, which have always been a special passion of mine. And when I was young and first getting into I loved a book that I had as a teenager that was called Galaxies by Tim Ferriss that some of you might have known. And it was a sort of a big production that had lots of photos and these sort of 3D maps of where galaxies were in the local group around us and in the local supercluster and so on. I thought it was the coolest thing. So I always thought, well, one day, you know, I really would like to write a book about galaxies and update things. And so finally this year that day came. And there's a lot, even though the story of galaxies in a modern sense starts a long time ago, we've really learned a lot about galaxies, what they are, how they evolve, and lots of details we'll talk about here just in the last 10 or 15 years. So as you guys know, there's really an explosion. We're in a golden age of knowledge, of research in astronomy. So it's an exciting time to update all of this stuff. So it really all began in a modern sense on October 4th, 1923. That was when this guy, Edwin Hubble, who was a somewhat cantankerous young astronomer, trekked up to his favorite telescope, which was the largest scope in the world at the time, the 100-inch Hooker telescope, and took a photographic plate. And that was of one of his favorite objects, the Andromeda Nebula, of course, as it was known at the time. No one knew really about the nature of galaxies. Several years before that point, there had been a great debate, of course, between Harlow Shapley and Heber Curtis about the distance scale, the size of the universe, and the nature of galaxies. Well, people for a long, long time, of course, had known about these spiral nebulae, as they were called. And in the 19th century, the Irish astronomer William Parsons, of course, the third Earl of Ross, had drawn their spiral structure very carefully and so on. And really no one understood what they were. Were they inside our own galaxy or not? Well, then along comes Edwin Hubble, who didn't win any popularity contests, but he waltzed out to Los Angeles and was very active as a young astronomer there. At the time, LA had a population of about 1 million. It was very much smaller, of course, than it is now. At Caltech, Robert Millikan had just won the Nobel Prize in Physics for measuring the charge carried by a single electron and for the photoelectric effect. Across town, Amelia Earhart was taking flying lessons. Walt Disney, a young cartoonist, arrived in the town that year with $40 in his pocket. So Hubble was really entranced with studying spiral nebulae with the 100-inch Hooker telescope. And most, of course, thought at that time that these nebulae were in our galaxy, whatever that meant, because the distance scale of the universe was not really understood very well. However, on this October 4th plate, Hubble was very excited because he found what he thought was a nova. And you can see the little tick. I hope you can see the screen okay. Is it okay, do you think? You can see little tick marks with the N there. He thought it was an exploding star, a nova, which was very exciting. And he took another plate the following night, and with somewhat better conditions, and went back down to his office in Pasadena and analyzed it and started looking at some other plates and so on, and realized that this was not a nova. He identified the star on some earlier observations, earlier plates that others had taken, and saw that it was a variable star. And as many of you know, it was a specific type of variable star, a Cepheid variable that varies in a very predictable and precise way. And he could tell, of course, because of the relationship of its apparent luminosity, how far that star was away. He was stunned to find out, to estimate that he thought it was 1 million light years away. Well, of course, now we know that it's 2.5 million light years away. At the time, he thought it was 1 million light years away, but that was 3 times larger than anyone believed the entire size of the cosmos was at that time. So with this one plate, this one photographic plate, he really had a eureka moment and set both the nature of galaxies in motion and what they are, and also the cosmic distance scale, although it would be measured to be larger yet. So that was really a key moment in the history of astrophysical research. He followed, of course, the notion that went back even further to 1912, before World War I, of the understanding that the universe possibly was expanding, because another astronomer, V.M. Slipher, at Lowell Observatory in 1912, had, with his spectrograph that was built in New England, found that many of these spiral nebulae had high so-called redshifts, that they were moving apart from each other. So the idea that maybe the nebulae were flying apart from each other and the universe was expanding predated Hubble. And this notion, actually tracing it backwards in time, led to the notion of the Big Bang, of course, which solidified as the origin of the universe. And by the way, I hope you can all hear me okay, and this should be, I think, very, very informal. If anyone, I can certainly take questions at the end, but if anyone wants to throw a question in there as the talk goes on, you should feel free to, I think, if that's okay with the moderators. Okay.
Yep, absolutely.
Okay, thanks. As with all sciences, the early days of galaxy research consisted primarily of classification, whether it be, bones or galaxies or butterflies or whatever. To really understand the nature of things, for a long, long time, scientists were classifying them and just understanding their basic properties. And of course, it was Hubble himself who in the 1930s began to classify galaxies and came up with his so-called tuning fork classification system of the basic types of galaxies, being spirals and barred spirals, spiral galaxies with spiral arms that have a bar that cuts through the center of the galaxy from which the arms emanate, or elliptical galaxies, these big fuzzballs of spheres of stars, gas, and dust. And he really took it essentially that far until the mid-1930s. In 1936, he published his famous book, which included all this information, and in which he coined the term the local group of our nearby group of galaxies. And that book was called The Realm of the Nebulae, and that's a very famous book in the history of astronomy. However, later classifications added lots of complexity and lots of other types. And a fellow who, near the end of his life, I had the privilege to get to know, who was a very nice guy, was Gerard de Vaucouleurs. He was a French astronomer who came over and spent a good deal of his career at Austin at the University of Texas. And at the end of the 1950s, he really expanded Hubble's classification scheme, adding lots and lots of detail to it, and tightness of the arms, types of elliptical galaxies, a sort of a mid-range type of galaxy called lenticulars that was kind of had some properties of a spiral and some of an elliptical, lenticular meaning lens-shaped, and other weird types of galaxies like peculiar galaxies that seem to be exploding or erupting or interacting with other galaxies. So the de Vaucouleurs system of classification, which is sometimes called the cosmic lemon, because in a diagram it looks like a big lemon or lime that's sliced then with all sorts of types of galaxies within it, is really the modern system of understanding galaxy types even now. He also wrote a lot about the nature of the bars, rings of encircling matter around galaxies, and how tightly or loosely wound the spiral arms were as well. So by the mid-20th century, astronomers realized that galaxies are the basic building blocks of bright visible matter in the universe, that stars, gas, and dust within them contain most of the matter in a galaxy, so they thought, and that our Milky Way, viewed from within, that band of light in the sky, we're inside it, and that's just one of many galaxies in the universe. For many, many years, astronomers believed the number of galaxies was about 100 billion in the universe, and that's the last few decades because they counted galaxies in the so-called Hubble deep fields, of which there was a whole series, and extrapolated those galaxy counts, which contained about 10,000 galaxies in a really small area of sky, over the whole sky. And that gave a number of about 100 billion. Chris Consolis, who's an astronomer over in the UK, did a study in 2016 based on the newest Hubble images at the time, and he pushed that number up to about 1 to 2 trillion galaxies in the universe. However, there's a rub, which we'll get to, because galaxies, as you may know, gravity is at work in the universe, and although many, many things are, the universe is expanding as a whole, gravity works to bring galaxies together, and over time, many galaxies combine into larger, fewer galaxies. So it may be that about 100 billion galaxies exist now in the universe, but a couple trillion existed in the early days, like we see in those Hubble deep fields. And of course, as you guys know, telescopes are time machines, and as we look back to very distant galaxies, we're looking back in time to the early history of the universe, and we can see galaxies, of course, now that formed a few 100 million years after the Big Bang. Closer galaxies, of course, to us appear much closer to the way they are to our present moment today. So where do we start with understanding galaxies? Well, we start at home with the Milky Way. This is a nice shot from Chile, which shows the Milky Way overhead, and you can see the small Magellanic Cloud there down near the dishes. I hope you can see that well down near the bottom of this shot. On any dark night, of course, away from city lights, you can see the luminous band of the Milky Way across the sky. It's our galaxy, of course, viewed from within. It's very hard to decipher the nature of a galaxy when you're inside it. We don't have any good external shots of the Milky Way, so it's taken a long, long time, and we'll get to this, to determine the spiral structure of the Milky Way, which was a long time coming. That's only about 10 years old, understanding really the nature of the arms of our Milky Way, but we think there's something like 400 billion stars roughly in the galaxy. We don't know, of course, for sure, because the most numerous stars, red dwarfs, are faint and they're hard to see over long distances. But it's something on the order of 400 billion stars in our galaxy. The Milky Way is a barred spiral, a fact that we didn't know concretely until the past 15 years or so. We thought it was a spiral just like the Andromeda Galaxy for decades. And there's an instrument called GLIMPSE that was on the Spitzer Space Telescope that mapped, an infrared instrument that mapped the galaxy's arms and spurs very, very well near the end of the first decade of this century, about a little more than 10 years ago now. And we know that it's a barred spiral and that we're about 26,000 light years out from the edge in the so-called Orion arm or spur. So it's good that we're out in the country, as it were, in a quiet part of the galaxy. Looking toward the constellation Sagittarius aims us toward the galactic center, of course. If you go, you guys probably know this, you have some pretty experienced observers and imagers, I think, in your club. But if you look between the cluster M6 and the Lagoon Nebula and draw a line between those objects, about the midway point is the rough direction of the galactic center. And it's a good thing we're a long way out from it because our galaxy has a supermassive black hole, of course, in it, about 4.3 million solar masses. And there are all sorts of messy things also going on near the center of the galaxy, like antimatter fountains, high energy radiation, frequent exploding stars, supernovae, and other hazards closer to the downtown section, if you will, of the galaxy. The galactic center, however, is shrouded. This is an infrared Hubble and combined shot of various instruments. But normally we see only about a quarter of the way toward the galactic center in our sky because there's so much dust that obscures the view, that absorbs starlight toward the very densely packed center. So when we look at Sagittarius and Scorpius, we're seeing only about a portion of the way toward the center of the galaxy. Well, like people, galaxies hang out in groups, some containing more than others. And, you know, gravity is at work even though the universe is expanding as a whole. Our group of galaxies, of course, named by Hubble in the 30s, is called the local group, and it contains at least 55 galaxies, most of which are tiny dwarf galaxies that look like just rich clouds of stars. The primary members of the local group, of course, are the Andromeda Galaxy, which I hope you can see here, the Milky Way, and M33, or sometimes called the Triangulum or the Pinwheel Galaxy. Those are the three big spirals, and the rest of the galaxies in the local group are little irregulars like the Magellanic Clouds and little dwarfs. You can see, of course, M32 here in this image just above the nucleus of the Andromeda Galaxy, and NGC 205 below it, both small ellipticals. And they're very representative of a large number of dwarfs that we have in the local group. The Triangulum Galaxy, as you may know, it's a relatively faint object. Excuse me, it lies about 3 million light years away. So, of course, the light we're seeing from it is about 3 million years old, traveled to us. It contains, you can see many pink areas here, so-called H2 regions of hydrogen gas emission that are collapsing gravitationally into new star clusters. It's a little farther away than the Andromeda Galaxy, of course, which is about, as I said, 2.5 million light years away. So although galaxies exist in groups almost exclusively, there's a lot of space between galaxies within groups, except for the very rich clusters of galaxies. And there's a heck of a lot of space between the groups themselves. However, funny things can happen in space, although they're generally separated by vast distances. Despite the fact that galaxies are moving apart mostly from others, galaxies do undergo collisions. And of course, you can see lots of them or image many of them with amateur telescopes. Even gravity is a force, it's always in play. It draws smaller objects together that are in close proximity. So the sky contains many examples of colliding or interacting galaxies. This is one of them, the so-called antennae galaxies in Corvus. And it's a very nice example. And of course, there are many, many, many others. Over time, galaxies often merge to form larger structures that are eventually not viewable as distinct separate objects anymore. This is not a terrible thing. It's simply what galaxies do. Because of gravity, they eat each other. Over time, our own Milky Way, you may have heard about 5 billion years from now, we'll have an interactive collision with the Andromeda galaxy. Most galaxies are moving away from each other, but the Andromeda galaxy is moving toward us at a fairly high clip, about the distance between Chicago and Milwaukee each second. So in about 5 billion years or so, we'll have a collision. It'll loom larger and larger in our sky, and they will eventually merge. And what Avi Loeb, the chairman of the astronomy department at Harvard, who studied this future collision and named it Milkomeda, because it will be a collision of the Milky Way and Andromeda. And the dynamics of that are fairly well understood. So 1 billion and 2 and 3 billion years from now, any people who are hanging out, on a planet in our galaxy will have a really nice, much, much larger view of the Andromeda galaxy in our sky. As we move farther out into the universe, of course, we encounter larger structures of galaxies. The Virgo cluster is the largest group of galaxies near us. It lies toward the constellations Virgo and Coma Berenices in our sky. It contains about 1,300 galaxies, and its gravitational center is about 54 million light years away from us. And as you know, in the springtime evening sky for us, there are zillions of galaxies, good stuff to look at in Coma and Virgo because of this from a dark sky site. The Virgo cluster contains all types of galaxies, including one of the largest nearby galaxies, the giant elliptical M87. The galaxy measures about 120,000 light years across. It's only a little larger than the disk of our galaxy, which is roughly 100,000 light years across. But it's spherical, of course, rather than a flattened disk like the Milky Way. So it contains about 200 times as much mass as our galaxy does. And it has about 3.5 billion solar masses, the galaxy. The black hole in the center of the galaxy. So it's on the order of 1,000 times more massive, the black hole in M87, than the central black hole in the Milky Way. And I don't know if you can see it here, but if you see on this image, if it's really transmitting well to others, you can see a tiny little bright jet very, very, very close to the nucleus of this galaxy to the upper right. And that's actually the jet that's of material that's being expelled from the supermassive black hole in M87. You can also see a whole cloud of kind of fuzzy stars, dots around the galaxy here, and those are actually globular clusters. The Milky Way has a couple hundred globular star clusters, leftover bits, drabs of stuff that didn't fall into the galaxy's disk of old stars. However, so a couple hundred the Milky Way has of globular clusters. M87 has more than 12,000 globular clusters. So this is an enormously large and massive galaxy compared to ours. Farther away in the cosmos, there are many, many more exotic kinds of galaxies. A distinct galaxy called the Einstein Cross shows the universe acting as a lens. The faint galaxy, you can see the spiral arms of it here, is in the center of this image. It's bending the light from a much more distant quasar that is precisely in back of the center of this galaxy, lensing it into 4 images of the star, of the stellar point that are around the center of this galaxy. That's actually the image of a distant quasar lensed, bent around and formed into that, which was predicted by Einstein in his relativity papers, of course, and once again, Einstein is right time after time after time after time. And we'll get to the mystery of what the heck quasars are and why it puzzled astronomers for a long time momentarily. The deepest images ever made of galaxies in the universe, as I mentioned, is this whole series of Hubble deep fields, the most recent one being the so-called Hubble ultra deep field. This shows infant galaxies less than 1 billion years after the Big Bang. So this is, in the earliest epoch of star formation. And one thing that's coming up on the horizon for us here is we don't really understand now what the sequence was of stars, galaxies, and black holes forming in the universe was. Which came first? Stars that assembled then into galaxies and then black holes in their centers, galaxies that then turned on with stars with the gas that they held, or black hole seeds around which normal bright matter then accreted. Nobody knows how the first matter in the universe got going yet. And if we ever launch the Webb Space Telescope, which is supposed to happen next spring, it's been delayed a couple times, as you may know already, that's one of its primary objectives, is to look at the earliest formation of matter and the matter sequence in the early universe. So there are more than 10,000 galaxies in this image if you subtract out the few foreground stars here. And many of the tiny bluish blobs are proto-galaxies in this image. And those are galaxies that came together to gravitationally to form normal galaxies later in cosmic time. It's possible that the Milky Way may have constituted something like 100 of these tiny galaxies originally that assembled and essentially made the disk of our Milky Way something on the order of 9 billion years ago. So again, galaxies merging as a structure method of how you make galaxies is really the answer to how they come together. Since the 1960s, astronomers have pieced together the story of strange, highly energetic objects they observed around the cosmos. In 1963, Martin Schmidt, who at Caltech, stumbled on a quasi-stellar object that puzzled him and alarmed him and stunned his colleagues. And it was an extremely bright stellar object. This is one of the first ones that was discovered here, 3C273. That was incredibly distant, but yet it was very, very bright. Astronomers then found other classes of things. They called these, for short, these were called quasars, of course, quasi-stellar objects, quasars. They also found Seyfert galaxies, named after the American astronomer Carl Seyfert. They found BL Lacertae objects, other weird, high-energy, inexplicable, distant things that were all completely different, about a dozen kinds of these things. However, by about the early 1980s, they started to figure out the solution to these high-energy, weird objects. And that was that they were all essentially the same objects, viewed with different geometries. They were black hole engines of young galaxies that were emitting enormous amounts of energy, and they were viewed at different angles and in different ways. So they all turned out to be the black hole-powered engines of young galaxies in the cosmos. There are also more recent closer galaxies that are powered by very powerful central black holes. For a long time, nobody understood that black holes really existed at all, even though the concept of black holes goes back more than 200 years to the 18th century. But the first verifiable black hole, of course, was a stellar black hole that Stephen Hawking and Kip Thorne made a bet on, and that was Cygnus X1. And it turned out that it did turn out to be a black hole verifiably by about 1990. At that same time, early in the 90s, a number of astronomers started finding supermassive black holes, many, many times more massive than stars, than dying massive stars, in the centers of galaxies with the Hubble Space Telescope. Now astronomers believe that essentially every galaxy has a supermassive black hole in its center, except for dwarf galaxies, which are not massive enough. And some of them are very active, like Perseus A here, which is a galaxy. You can almost see the chaos going on with this galaxy and the stuff that's being shot out of its black hole. Others, like our central black hole, are quiescent. They had very active periods early on, and there's nothing near the black hole that's really left to eat for the moment. So a lot of the material isn't being shot out, and they're essentially asleep. So galaxy astronomers sort of equate periods of black hole activity as like a sort of a cosmic flu. Most black holes in the recent universe here are sleeping, but if stuff falls into them, they can have this episode again and reawaken. This is a really energetic one here that's a high energy black hole in galaxy, as I mentioned, Perseus A, NGC 1275. Okay, galaxies exist in a gently balanced state between stately grace and internal upheaval most of the time. Sometimes through their lives, they go through crises. And as galaxies interact, as galaxies, as in this group, pass close to each other, that can again fuel the black holes and send them into chaos and more episodes of star formation. Well, eventually, this is Centaurus A. You guys might know this or have viewed it in the southern states or in the southern hemisphere. In Centaurus, of course, NGC 5128, great interacting galaxy. And this is kind of a poster child galaxy for two galaxies that came together and merged. And now there's a chaotic jumble of stuff going on in this galaxy. So here's a future look, maybe, at what the Milky Way and Andromeda will look like in the distant future. And most extragalactic astronomers now think that this is how you get elliptical galaxies, through mergers. Most all normal galaxies have disks early on, and you get elliptical galaxies that are sort of mostly devoid of star formation and are big jumbled messes through mergers. Most of you have heard of cosmic inflation. You know, that early period in the first fraction of the second after the Big Bang, when the universe went from about the size of a pea to about the size of a grapefruit almost instantly. And this is a hypothesis that came from two different groups in the 1970s. And most cosmologists think that inflation happened as a period in the very early universe because it explains a lot of stuff that we see now observationally. If inflation is true, and this is where it starts to sound like science fiction, but it's not. If inflation is true, then the visible universe that we see is not nearly the entire universe. And in fact, the universe could even be infinite, which really sounds like science fiction. But let's set inflation aside, even though it's probably true. How many galaxies exist in the universe? We were talking about that. Probably 100 billion or so at our present moment in time. And let's conservatively estimate the number of stars in the galaxy and say that maybe 10,000 billion stars exist in the visible universe. We know in recent years we've seen planets all around us going out to the nearest stars, generally in the galaxy, extrasolar planets, so that planets are common within galaxies. Shouldn't life be common in galaxies as well? Well, we don't know, because we know still of only one place where life exists in the universe, right here. But we know that chemistry is consistently the same throughout the universe through spectroscopy, and we know that that organic compounds, that amino acids, even the simplest amino acids, glycine, exist in comets and asteroids and so on. So it would be very naive to continue the trend of thinking that we're the center of everything and the most important thing, and there isn't a lot of life out there, I think. But yet, it's a very, very, very large universe. So detecting it, running into any other sophisticated life is extremely unlikely because of the cosmic distance scale. So there may be a lot of life out there. We may not have them land actually and have dinner with them, however. Well, if galaxies have a lot of life in them, where would this occur? They may have zones, and this is really sort of a really new area of galaxy research that's just a few years old, the so-called galactic habitable zones. Rocky worlds, of course, offer the best hope in terms of life as we know it, and this would mean metal-rich stars. So a galaxy like the Milky Way may have a habitable zone mainly in the spiral arms, and maybe from 10,000 to 30,000 light years out from the center. Farther out may mean fewer metals from generations of stars, and farther in may mean greater dangers. So we may be on the sort of slightly outer edge of where it's likeliest to have sophisticated life get going and exist for a long time in a galaxy like the Milky Way. However, after 94 years after Hubble's discovery, we still only have one place where we understand life. We're just beginning to understand the most sophisticated aspects of galaxies. And so it's going to be an exciting ride over the next decade or two as well to learn much, much more about them. So I thank you for having me tonight. We'll stay tuned for more scientific progress on all this stuff. And I would be happy if we have any time left. Sorry, you know, astronomers are talkers, so forgive me. But if we have any time left, I'd be happy to take questions about galaxies, the book, the magazine, amateur astronomy, anything else you want to talk about.
Thank you, David. That was great, and we appreciate your time. And yes, of course, we have some time for questions if you do.
Sure, of course.
I think a few people were counting on that. So, okay, so we have several questions in the chat. Does anybody want to just speak up though? And
should I be looking at the chat and just looking at them there?
You can, sure.
Okay. Okay.
Making it easy on everybody.
Now, I'll go up to the start here. Okay. Okay. Feel free to post questions. You've seen the image of the M31 and the variable shown. Do you happen to know the field of view of that image? It's very small. I can actually, that's something I've never thought about calculating, but it's the Andromeda galaxy. It's about
about 3 degrees, right?
It's about 3 degrees, and it's about maybe a tenth of the overall disk size. So something like that.
So it's only the very middle of a galaxy then.
That's right. Yeah.
Okay.
But no one has ever asked me that. That's a great question before, and I've never really thought about that. I've been so awestruck just by the image itself and the realization of Hubble.
Yeah.
Okay. I'm sorry.
No, I was just going to say something snide about you getting quizzed. So
no, please do.
The quiz after the talk. Go ahead.
You know, the questions, I've done some talks in the past where it's just a Q&A. those are by far the most kind of fun kinds of talks to give. It's much more fun to be talking to you guys than just to be talking about galaxies. So this is actually good stuff. Yeah.
Yeah. This is Bill. I asked that question there, and you had me at variables because I'm a variable guy, a star guy, and I'm just curious how close to the center of that variable was, and I think you've answered it. It's pretty darn close.
It's pretty close. And, I mean, if you want to email me a reminder at editor@astronomy.com, I mean, I'm flying by the seat of the pants right now, but we could measure that, and it would be interesting to know. I'm curious now. So we could measure it and get a precise distance if you want, if you're that curious about it.
Well, I'll take you up on that. Yeah. You had me at variables.
Yeah. When, for Hubble to freak out and, write a sloppy var ! And cross out, he was pretty excited too. And it was Henry Norris Russell, who carried a lot more weight than Hubble did at that time, who the better part of a year later then went and presented that to the American Astronomical Society so that people wouldn't think that Hubble was nuts, essentially, and read a formal paper about it. So, okay, I never got, this is from Frank, I never really got what makes a lenticular galaxy lenticular. Is it the idea that when viewed edge-on, there isn't just a bulge at the core, but a bulge that's more spread out toward the edges of the galaxy? Yes. So it's that lens shape that is the bulge spreading into the galaxy. So it shows a flattened core that is like a smaller version of an elliptical galaxy, but it's flattened and pulled out, which you don't see an enormously bright, large hub like that in a normal spiral or barred spiral. And then it's also the spiral arms in there, though. So it's got those characteristics of both spirals and what de Vaucouleurs originally thought was a sort of a hybrid between the two. And it's still not clear dynamically why lenticulars form that way. So there's still, astronomers aren't going to run out of, they have job security still, they're not going to run out of things to decipher yet, with a lot of this stuff.
Thanks. That's the first time I understood that.
Okay. Also from Frank. I noticed Galaxies is dedicated to Brian May. Yeah, an astrophysicist more widely known as co-founder of the band Queen. I've enjoyed your 3D collaborations with him, Mission Moon 3D, and more recently Cosmic Clouds. Thank you very much, Frank. Bless you. Maybe we can get Brian and I to come back here and give a talk about that. He even had a surprise appearance in your astrotourism DVD. That's right, for Northern Arizona, which enhanced my trip there last year. Any good stories to tell? How much time do we have here about your partnership with him and how it came about? Yeah, well, it's a long story, but to cut it very short here, I got to know Brian about 10 or 12 years ago now, and all through a mutual friend, Garrick Israelian, who founded the Starmus Festival with Brian. That's this European science festival to celebrate the sciences and also music, stars and music, Starmus. And it's a long story, but after, Brian's family was very, very disenthralled and disenchanted and sad about him around about the spring of 1970, when he had about 95% of his PhD finished in, of all things, studying the zodiacal dust at Tenerife there. And he quit to take up with this band, Well, it all worked out okay, in the end. And by the time, Night at the Opera came out, the family, had realized it was fine. But, 35 years later, it was Patrick Moore, who was a childhood inspiration to Brian, convinced Brian, you got to go back and finish your PhD. And so he did that. And Garrick turned out to be one of his advisors at Tenerife there. And so they got to know each other. Garrick's a musician as well, and they got to talking, and this Starmus thing came up, and they kind of pulled me into that just after the first Starmus got going. And so that's how I got to know them. there are very many Brian stories. I don't want to bore you, but the Arizona thing came about because he had heard that we were going to hang out there, and he hadn't been to Lowell to see the B plate of the Pluto Discovery plate. The A plate is in the Smithsonian, but the B plate, you can go, and if you sweet talk Brian Skiff in the right way at Lowell there, he'll, you got to think, Brian, what the hell are you doing? He'll pull this glass plate out of the sleeve and hold it up. Jesus, if you drop the thing, it's a catastrophe, the history of science. So anyway, Brian got sort of the notion that we were going to do a Flagstaff and environs kind of hangout there and produce this thing, and said, I'd really like to go as well. And so when we talked about Meteor Crater, he said, well, I thought he was joking, but he said, well, should I rent a helicopter? And come on, and he said, oh, does that sound too rock star, blah, blah, blah. So we get out there, and he rented a helicopter, and we flew over and into Meteor Crater in a helicopter, which was mind-blowing. So that was one, when Brian teases you about things, you have to be careful because he may not be teasing, is one Brian thing. Okay. But he's a wonder. He's in very fragile shape right now, and we think he's okay, but he had a heart attack recently, and so that really stunned him, and he's been recuperating and recovering, and we think is fine and is stable. But it was the last 2 months really have been a very scary time with Brian in his life. So really, that really changes your outlook on things, of course, when something like that happens. So we'll hope that Brian is back to his normal self soon. Okay. I love jets. Is that the last one, 629, or am I missing? Oh,
yeah, there's a couple more.
Okay.
Justin, there have been some recent articles about the data uncovered by the WAM telescope and its ability to study the Milky Way galaxy. Are you able to give any additional details on the discovery of emission lines from the inner galaxy? This is a good quiz.
Not really, no. And I've been to WIN there at Kitt Peak, and I've heard about what they're doing with it, but I have not in recent days read about that because there's been so much going on. So maybe the questioner can actually tell a little bit about that, if you wouldn't mind.
Justin, you want to jump in?
Oh, sure. Yeah, it was essentially this telescope is using H alpha to study the interior of the galaxy, being able to see past the dust, and that was essentially the big kind of wow factor was now that this telescope has the ability to kind of cut through that dust and start to see radiation coming from the interior of the Milky Way, which has really never been studied in detail before. And I knew that WAM telescope was near you in Wisconsin, so I just wasn't sure. And it's very recent. I think it was just 2 days ago the paper was released. So I just wanted to see if you had any insight on that since that release.
I will have to check it. I did not read that in the last 2 days, but with infrared telescopes have been looking more successfully toward the galactic center in general for some time now, and have mapped the region around the black hole reasonably well, velocity maps and so on. And there was this a few years ago. It's actually about 2 years ago now. There was a star cloud called G2 that was moving and was supposed to fall into the Milky Way's black hole and maybe re-energize it and have a burst of energy in X-rays and gamma and everything, and that didn't happen, and it's not clear why that didn't happen. That was a little bit of a disappointment that astronomers thought they were going to predict a kind of a local black hole event for the first time. So I will check on the WIN scope in the last couple days, but I did not read that paper or the report about it. So you got me on that one.
No worries.
Justin, why don't you ask your next question too, since you're asking about the Drake equation?
Oh, yeah.
Already on.
So there was a recent update to the Drake equation. That over the years it had been, we had estimated that there's some 10,000 potential advanced life forms in the Milky Way, and recently it was updated to this interesting number of 38. And when you were talking a little bit about habitable zones and things like that, it brought to mind that recent study, and I didn't know if you had any insight on that.
Well, that's whether you estimate a low number of potential civilizations or a high number, or even if you're talking about simple life, there could be microbial life in our solar system, of course, from between Mars and Pluto and all the icy moons. You can make convincing arguments from the Drake equation either way, I think, and it's not clear that there's enough evidence to say one way or the other. Now, to make an estimation that's that specific, regardless of whether you're conservative or liberal with what you think about about life getting going in habitable zones, is silly, I would say, to say something like 38.
Right.
All we can say is it may be relatively low, or it may be enormous, the number of civilizations in the galaxy, and then there are lots of other galaxies too. But nobody knows, and there's no evidence for it one way or the other than probabilities. And so it really is all guesswork. Carl Sagan used to be on one end of things and say that, life undoubtedly is throughout the galaxy. And he was actually one of the early proponents of what came to be called cosmochemistry, of being very literate in organic chemistry as well as astronomy. But there are some, astronomers who, think that we're the only life in the universe, and they're PhD astronomers, but they're really just opinions. And based on, one data point, we really can't say. I personally, knowing about chemistry and spectroscopy and the way atoms form in the universe, which is by electrochemical attraction. We don't get diamond crystals and topazes and iron oxide and everything else by accident. Those atoms are drawn together in crystal lattices and in the molecules that make up life in specific ways that the universe orders because of their electrochemical attraction. So we know that you can make, presumably plenty of simple organic molecules easily in the universe. We have evidence of them. The only comet that's been returned to Earth had glycine in it. The Stardust mission return that landed in the Utah desert, the only one, had a simple amino acid. Now, granted, it's a long hike, as Richard Dawkins likes to talk about, between the simplest amino acid and getting to RNA and DNA and self-replication and so on. But biologists and chemists are studying that in laboratories, and are, many of them are think that it's not, something that well, put it this way, it happened fairly quickly in the early history of Earth, and maybe multiple times, given the hazards to early life from the late heavy bombardment of lots of stuff coming in, and striking Earth, early Earth. So to me, it would be bold to think that, out of, 10,000 billion star systems, were it, that seems awfully pre-Copernican, to me. But who knows? We don't know. We don't have any evidence at all of anything. And part of the problem is the distance scale. And forgive me for going on with this, but you guys know, if you take one astronomical unit as a centimeter, the Earth-Sun distance, 1 centimeter. So we've traveled physically as human beings a tiny, almost immeasurably small fraction of that to the moon and back. Now, on that scale, the edge of the solar system is 10 football fields to the right. That's just the inner edge of the Oort cloud. And it's 4 times farther than that to Alpha and Proxima Centauri, the nearest star. The cosmic distance scale is enormous, even to the nearest stars to us. So I tend to think there's probably a lot of life out there, and we're physically never going to travel to it, unfortunately, or fortunately, however you see it.
That is a paradox. Well, thank you.
But we don't know. We don't know.
I suspect the scientists who did this study said it's a surprisingly small number, and a non-scientific manager type whom I've probably worked with once or twice said, listen, I have to have a number. Just give me a number.
Yep.
Because 38 is an awfully odd.
Yeah,
No, I'm not buying that either.
That seems awfully suspiciously precise, given that we have zero knowledge of what it might be, really. Yeah.
38.7.
But you got to have fun with this stuff, too.
Sure. You also, one thing I always say when I talk about this sort of thing with friends is you have to think 4-dimensionally, time-wise. How long have human beings been on this earth, and then how long have we had a civilization? And so if you look at not just the volume of the universe, but the time,
right?
In the past, how many civilizations are where we are in the universe? The answer would almost certainly be none. They're either going to be, life is either way microbial in nature, or way primitive compared to us, or it's gotten to where we are and either self-destructed, like we seem to be determined to do, or it has moved on to something, even more, something beyond that. So,
and they're very good, aside from our own self-destructive tendencies, there are very good astrophysical reasons to think that, civilizations may have a finite time scale.
Right.
Yeah, that's absolutely right. Yeah, and if you talk to Seth Shostak, Jill Tarter's right-hand guy, if you will, at the SETI Institute, to even detecting life, you basically have to have things exactly right, in a pencil beam kind of way to get a signal, even at the right time and the right place, that's directed essentially right at you. And so even detecting, even SETI, let alone for sure knowing about them or traveling to them, is mind-bogglingly hard. Anyway.
Yeah. Good talk for an astronomy club. Frank Kane's question. Can you see these?
Yes.
Frank? Okay.
Yeah.
Okay.
I appreciate that you didn't take the easy route of only talking about galaxies for which they're pretty Hubble photos in your book. You found amazing images for a variety of Earth-bound observatories. As well, what was the process like for finding and licensing the images to support the text of the book? That's a great question. And I tried to, first of all, have a blend of the best observatory stuff and really nice amateur shots. And there are quite a few sort of high-end amateur shots that are great in the book. My frustration on the other side of that coin is that I started, and my pal Michael Bakich at the magazine, who just recently retired, did a bit of a sort on this as a favor to me and sent me a disc with about 600 images. And I think we ended up with just a couple hundred or so in the book. I sent them about 400, and our original goal was to have 350 images in this book, and unfortunately the editors at Random House sorted them down as well. So we, it seems mildly disappointing to me, even though there are a hell of a lot of images still in it, because, you want to put everything you possibly can into it. But I sort of tried to take a balance between, Hubble stuff and the best ground-based observatories, and then a lot of really nice amateur astronomy type, because I don't want to run images of deep sky objects that are so different than what we see in an eyepiece scale-wise that it's all, I'm an old-time observer. I want to have that connection to how they really look, to some degree. Okay. Sir Patrick had actually come over from the UK and gave a talk to your group in the mid-90s. I'll be damned. He was a wonderful guy, and Brian and I both, lament that we lost him in 2012, as you guys know, as a guest of Don Trombino. Oh yes, who was a solar specialist. Oh, I didn't know Don was a member of your club. The UK and all of Don Trombino's work, and Mr. Trombino actually became a member of the RAS. Actually had one of its members also a member of the RAS. I'll be darned. Wow. Well, I didn't know about that connection to Patrick and to Don Trombino as well. That's great background and history to hear about. Yeah. Our eclipse tour is still a go with COVID.
Trick question.
would our travel partner, Travel Quest, love to know the answer to that? They're pretty freaked out about whether in December everyone will be going to South America or not. We don't know. I mean, I think we're going to have to wait another month or two and see what happens. We just don't know. I think it would be impressive if we have big groups of people traveling on airplanes to foreign countries by December. I really do. But who knows? We'll see. I hope to go to the eclipse then. I presume you're talking about the December event. Probably. Yep.
Yeah. Probably.
Yeah. I wish we knew. I really do. But
Bob says yes.
Things have flared up again, and we hope that 2 to 3 weeks after July 4th here, we don't have another, major surge everywhere. So we'll have to see. Okay, as a matter of fact, more Don Trombino's business card. He was a curator of the Missouri located here. I did not know that. Wow. I'll be damned.
Cool.
Huh.
And Tricia found a link, so we can get signed copies of the book. Very good. Thanks, Tricia.
Tricia, thank you, Tricia. You're very kind.
Okay.
Okay, and Patrick was actually over here a few times, and I don't know if anyone has any other questions of any kind.
The image is backwards. I didn't know it's going to be backwards.
I'm sorry, I didn't get all of that.
No, my image on Don Trombino's card is backwards. I didn't know.
Wow. No, yeah, see, yeah. I'll be damned. Wow, what a small world it is. Yeah.
All right. Well, thank you very much, David.
Well, thank you for having me. I hope that wasn't too much all of a sudden, but there's a lot to talk about with galaxies.
No, there is, and I think everyone enjoyed it. It was quite interesting. And it is an astronomy club after all, so yeah.
Well, thanks so much for having me. I wish you all very well, and lots of fun. And let's hope when all this is over, we can meet up at a star party or maybe at an eclipse and hang out.
Maybe, yeah. All right. Well, okay. Well, take care and talk to you later.
Thanks so much.
Feel free to hang around if you're bored as well.
I had 6 meetings today, and I haven't had dinner, so I may go to dinner if that's okay.
Food is also good. That's also good. Yes.
It's crazy.
Right. Yeah. Indeed. Thank you very much.
Thanks so much, everyone. Best wishes to all of you.
All right. Thank you, David. All right. So next up then is our mini programs, and we're going to start off with our Astro Photos of the Month. If Derek is ready to go, or
I am ready to go. I'm always ready to go.
All right then. I'm not always ready, so I like to give everybody else the benefit of the doubt.
No, it's all good. So as you know, we have been battling weeks, if not months, it seems like, of poor weather conditions here in Central Florida. We are definitely in the midst of our summer observing season, which is basically lack of observing season. But we do have a couple of photos from several individuals. So if you happen to see your photo come up as I share my screen in a few minutes here, a few moments, just go ahead and unmute yourself and just give us a little brief discussion about these images that we have here in our program. So let me go ahead and share that. All right, so our first image is from Mark Femininio. There we go. And this is his recent image of Comet Neowise F3. And this is, I believe, 85 millimeter exposure. And just, I think it's only 3 seconds exposure. He said he just got a new camera and lens setup, so he was just trying it out, and he decided he had some nice clear skies. And this is the result. I'm not sure. He didn't give me any information about the camera information. I don't believe he's logged in right now. But anyways, yeah, so there's his image. So we have some also some other members of our organization that have actually observed comet NEO-Eyes. So if you haven't had a chance to do that, don't worry. I'll talk more about that a little bit later on in our What's Up in the Night Sky mini program. Last night, I got a chance to take a trip down to Kennedy Space, or near Kennedy Space Center, to capture NEO-Eyes. Here's the image right here. You can see a beautiful tail. Actually, if you look closely, and it's hard to, depending on your monitor screen here, the tail extends quite a bit. It's several degrees in size. But we can see here is a Launch Complex 39B, 39B. I haven't slept very much in the last day or so because I had to get up at 3 a.m. to drive down here. But you can see here, this is a vehicle assembly building here. So anyway, thankfully we've had some clear enough skies in the morning, which of course is one of the best times to observe in Florida during the summer months. Our next image comes from Jenna. I apologize, I don't remember Jenna's last name, but this is Jenna's image of the Orion Nebula, M42. Is Jenna on here? All right, it doesn't appear. So Richard, you did send me these images. Did she give you any more details about these? This image here?
No.
Okay.
I forwarded you the email she sent me. So
okay, gotcha.
They were taken by Jenna, and she's a CFAS member.
Okay,
and,
yeah, great image of the Orion Nebula. Lots of nice detail in here. And at first, our next image is also taken by Jenna. And at first, I have to admit, I was not really sure what this was. It looked like a star field, but then I realized it is part of the Pleiades. You can see several of the bright stars in the Pleiades, and including the reflection nebulae. So yeah, at first when I saw this image, I was a little confused. It just looked like a star field, but I wasn't quite sure. But then, of course, giving a little time to look at it, I was able to finally make the conclusion that this is the Pleiades.
You can see some of that nebulosity.
Exactly, yeah, the reflection nebulae and some of the brighter stars. Again, unfortunately, there isn't any information as far as telescope and camera and exposure time. So unfortunately, I'm not able to provide that information to you. But hopefully, I believe Jenna is on the group's I/O message board. So if you're interested in both of these images, you can reach out to her there, and she should be able to give us information about these images that she's recently taken or has taken. Richard, this is your image. I'll let you talk about it.
This is M13, taken from my backyard here in Lake Mary. Every time I go on a trip, I don't believe in checklists because I always leave something off the checklist. So I set the complete system up in the backyard and make sure it works by taking an image. And this was an Esprit 150 refractor and a new focal reducer from Starizona that dropped the focal ratio down to f5.5. So it made it a bit faster. Starlight Express Trius camera, and let's see, it was on a Paramount MX Plus, and it was taken with the very first production, the Sky Fusion hardware product from Software Bisque. And every single thing that I used to take this photo was stolen in Kansas City on my way to Colorado. So this, in a sense, it's like the last hurrah for that setup. Yeah. So, but yeah, M32 globular clusters are great targets for the city. They stand up to light pollution quite well, and you can see I even got some of the color from the stars to come out.
Now, did you happen to take multiple exposures to get the core to stand out? Because I know sometimes when you overexpose or when you expose for a long time, the core gets blown out.
No, my trick with globular clusters is short exposures. I only do about 2 minutes. That chip is very sensitive, and it's a very clean sensor. And I did about half an hour of 2-minute exposures on red, green, and blue. So it's about an hour and a half worth of 2-minute exposures. So you get that signal to noise down. It's really nice, smooth, and you preserve that dynamic range because you don't saturate. So sometimes less is more. Deep, long exposures aren't always the best, especially when you want to retain some star color. You really don't want to overexpose.
Excellent.
So,
anyways, and unfortunately, that's all we have. I also wanted to mention, I wanted to put this in here, Richard, but of course, in my observing report later, I do want to mention that this also is, I believe, part of your observing challenge for this object too, because that was one of our observing challenges as well. So I decided that, well,
I didn't sketch it, but yeah, all right.
Well, you did mention that you can also take photos. So in the observing challenge, so you don't have to sketch it. You can also take photos. If you can submit a photo of the observing challenge as well, that is technically observing it. So there we are. So that's our astrophotos, and hopefully, I hope to see. Hopefully, we'll get some more Comet Neowise images. That's actually going to be part of the observing challenge this month. So I'll talk about that when I get to that point. So hopefully, see some more images from all of you. And yeah, there you go.
Okay, good. I'm up next with our certificate of the month. Let me get my presentation going here. All right, so we've already done all of that. Observing programs from the Astronomical League. Why do you want to do it? Get a pin and certificate, personal glory, all these sorts of things. It's a really nice structured way to get into an observing program, to learn something about some particular types of objects. And, everyone who's a member of CFAS is automatically a member of the Astronomical League, and you are eligible to participate in these observing programs. And you can get a certificate, and or some programs also do a pin that goes with them. And so it's bragging rights when it comes down to, globular clusters or variable stars or double stars. You can say that you are more than just simply an armchair observer. You actually know a little bit about astronomy. So every month I like to highlight a new observing program. So I'm trying to do some really easy ones here. So there's actually a binocular double star program that you can participate in. The requirements are pretty simple. It's just your eyes and binoculars. You don't need a telescope at all. And it goes hand in hand. There are several other binocular observing programs you can actually work on at the same time, and I may cover them in the future. There's a deep sky binocular program and a Messier binocular program where you identify and find these objects in the sky with a pair of binoculars. And I remember for many years I fought against binoculars. It's like, I want a telescope. I want a telescope because a telescope is, I want a big, awesome tool. It's like owning power tools or something. And it's like, well, binoculars. And I'm like, please, it's like giving me a sweater for Christmas. I want a telescope. But I was wrong. Binoculars are really awesome. The views are quite spectacular, wide swaths of sky. And it's a great way to learn your way around the sky and to learn the context of where things are in the sky relative to one another. So it's really great because you're looking and you see all of Leo and you're panning through there with binoculars, and then you see these little smudges and you realize that's the Leo triplet. And you can see the whole galaxy, the whole constellation, but you can see the little triplet there. Or you're looking through Cygnus and you start to pick out some deep sky objects. They're very small, but if you're paying attention, you can spot a lot of them. Anyway, that's not what we're talking about. We're talking about double stars and learning about double stars. So there's a list of 120 double stars, and some of them are multiple stars. So it's not just double stars, but there are multiple, some consist of more than that. And you choose any 50 of them. 5 pairs of them you will split naked eye and with binoculars. And it is possible to actually discern many double stars naked eye. You can see that there's actually 2 stars there. My favorite is Mizar and Alcor in the handle of the Big Dipper. And I my eyesight is not super awesome, but I can split those two stars pretty easily. So, more information, same as always, visit the Astronomical League website if you want to know more. They've got a write-up about how to use binoculars and more information about the program, including you can download a spreadsheet, Excel or Word or a PDF of the list of double stars that you can go through. Here is, I actually put up the URL. This is the list of double stars for you right there. And if you miss it, you can rewind it in the program later. So that concludes the Astronomical League Certificate of the Month. A few words about our Lunar Observing Challenge. I may expand on this a little bit more each month in the future, but last month the Lunar Challenge was Tycho, or Tycho, depending on who you listen to as to how to say that, Kepler, Plato, and Petavius. Some very interesting and prominent craters. And I do not have any sketches because as I was telling you at the beginning, my entire eyepiece collection is gone, and I have not replaced all of that yet. So our challenge for this month is going to be Maria, or as my wife says, Maria. If you can spot these Marias on the moon, the Sea of Serenity, the Sea of Crises, and the Sea of Moisture, I encourage you to sketch them. They look very different on a night-to-night basis. In fact, I would encourage you to observe any of these Maria multiple nights, a night apart or a couple of nights away from each other, and the difference is quite striking when you look at that. In fact, looking through a telescope, it's amazing over the course of just an hour how much the sun moves on the surface of the moon and how the shadows will change. And on a night-to-night basis, it's actually it's a tremendous change. And that concludes that. See, believe it or not, I am not going to talk all night. Now we're going to go back to Derek, who is going to talk about what's up in the sky and our observing challenge. I'm sure a particular visitor to the inner solar system is going to feature largely. I'm going to shut up now.
Yes, so basically what we're going to be doing is for our normal observing what's up in the night sky this time of year. I'm going to go ahead and start sharing my screen here. So I have the time set to, well, I wanted to set it to 11 o'clock. So because we're close to the summer solstice, pretty close. We're past it, which is good, which means the sun will get lower and lower in the sky, and our days will grow shorter and shorter, which means we don't have to be waiting till almost 11 o'clock at night to reach pretty much astronomical twilight, and we can actually start truly observing. So I wanted to set up the sky to about 11 o'clock at night. So again, if you're not somebody who is a late night observer, this time of year is a little difficult for you to observe. But of course, the other thing that we have to deal with this time of year are those afternoon thunderstorms, and that usually sends in a lot of clouds. But there's those occasional nights where we may end up having clear skies in the evening. So what I like to do is I want to focus on a few objects that you can see this time of year and that are part of our observing challenge. And then we'll focus more of our efforts into the early morning, because to be honest with you, our early morning skies are the best time to do observing in Florida during the summer months, because as the temperature cools down, the clouds begin to dissipate, and while we get increased humidity and generally transparency gets a little degraded, we at least get clear skies so we can do some observing. Now, the first thing you're going to notice is you can see here we have the beautiful Milky Way core up this time of year. Best time to photograph the Milky Way. Of course, Richard is going to be doing a nightscape workshop very soon, and you'll learn more about how to compose that and the best way of observing it. And this is the time of year when the central area of our Milky Way is located. And this is technically the Sagittarius and Capricorn arm of our Milky Way that we essentially see. But of course, located here kind of near the south this time of year, one of the brighter stars in the sky right now is the star Antares. And Antares is a massive supergiant star. It's not as big as Betelgeuse, but it's pretty up there in size. And of course, the term for Antares literally means not Mars, because if you or somebody back in ancient times observing this object and you had Mars associated with Mars in the sky, you'd want to, of course, make sure that you don't get it mixed up. So that's essentially what's anti-Mars, if you will, because of the color of that object. And of course, this constellation, this constellation is part of Scorpius, the Scorpion. Here we have Antares. We have the two stingers, or two claws of Scorpius. Down here we have his body. Over here we have Lasath and Chula, making the stinger stars of Scorpius. Now, if you take the stinger of Scorpius and you kind of make a arrow marker between the two cat's eyes, or Lasath and Chula, and this bottom star here and this star, this points over to an area of the sky known as Sagittarius. And Sagittarius is our archer, so we can go ahead and bring up a kind of photo or an illustration of the constellation here. We can see we have Sagittarius here. And of course, Sagittarius is famous for an asterism called the Teapot. And the Teapot, we can see here, is the upper region of Sagittarius. Of course, Sagittarius is actually a very large constellation. The backside of this centaur, half human, half horse creature, the back of it is located here, and of course we have the front here. But the thing that most people usually see is the teapot. So of course these we have Nunki right here, or excuse me, Casparalis. Nunki is this one right here. That's Nunki. This is Casparalis, Caus Medea, and Caus Australis. This is the bow of Sagittarius. But right here we have the top of the teapot. Let me try to get rid of the text here. We have the top of the teapot. Here we have the kettle, and here we have the spout and the handle. And Corona Australis, I always see Corona Australis as the lemon wedge that you would put in tea if you're somebody who likes lemon in your tea. Now, coming up here in this area of Sagittarius, just above Caus Medea and Caus Borealis, basically these two stars, if we follow to this star here, which is Al-Nasi, which is essentially the top of the spout, and we follow that up here towards the core of this actually area here, kind of in this area is located where we would find Sagittarius A star. That is our central supermassive black hole source that's located in the center of our Milky Way. But visually, what we can see here, if we zoom in, we can see a couple of nebulae. And this one is what a lot of people consider to be the Orion Nebula of the summer here in the Northern Hemisphere. And this right here is, of course, the Lagoon Nebula right here. We have the Lagoon Nebula. And Lagoon Nebula, or Messier 8, is this large swath of gas, especially star formation-rich hydrogen gas. And this is your first observing challenge this month. We have M8, the Lagoon Nebula. And just above the Lagoon Nebula, especially being the fact that Richard was talking about pair of binoculars, depending on the size of the binoculars that you're using, you should be able to actually see both the Lagoon Nebula, Messier 8, and the Trifid Nebula, Messier 22, just above it in the same field of view. Now, Messier 22, or the Trifid Nebula, is actually a combination of two types of nebulae. We have a reflectant nebulae caused by the reflectance of dust and gas along this star here. And we have an emission nebula located here, which is being illuminated by these two bright stars in this part of the sky. So we have two beautiful objects that are located in Sagittarius. So these are the two observing challenge objects I have for tonight. However, there is one more object I want you to try to observe in the next month or so. And right now, that next object is located in the early morning, but we're going to start seeing it in the evening. So what I'm going to be talking about here is, before we move on, I'm going to go ahead and zoom out. And of course, we can see here just to the left of Sagittarius, we have the planets Jupiter and Saturn. So of course, the planets are getting higher and earlier in the sky or earlier in the day. You don't have to wait till 3, 4 o'clock in the morning anymore to make your observations of the planets. As we get into August and September, Jupiter and Saturn will be very easy to observe early in the evening. And of course, eventually we'll have Mars in the sky earlier as well. But what I want to talk about real quickly here is that there is a comet currently in the sky right now, Neowise, F3, 2020 F3. And this is this has been observed by the Neowise satellite. This is an infrared wide surveyor of looking for near-Earth objects, particularly asteroids and comets. And this is one of them that's been found. What's really nice about this comet is that it has made a very, very close perihelion approach, about 25 million miles from the sun, and it's now making its way back out into the depths of space. And right now, it is currently a morning comet, but we think that around July 11th, July 12th, July 13th, eventually it's going to pass this transit of the sun, and it's eventually going to be viewable in the evening sky. So what you want to look for is over in this area of the sky towards the northwest, you will start to see Neowise start to emerge as we get after, pretty much after next week into the later part of the month. Now on July 23rd, Neowise is going to make a close approach to the Earth, about 60 million miles from the Earth. And this is going to happen when the comet is going to be up in the sky. And it's said that the comet is going to remain very, very, very good in terms of magnitude for a while. Right now we're looking at, I think the magnitude is about 1.7, which is very good. But we'll start seeing a reduction in magnitude or an increase in magnitude probably by the middle of July. And as we get later into July, it will start to fade. So right now, it is looking unbelievably amazing. So as you can see in the photos that have been taken by myself and Mark, you definitely want to go out there and observe them. But it's going to start to appear in the northwestern sky after sunset. So this is going to hopefully happen within the next week or so. So if you're not an early riser and you want to take a look at it, this will be your best time. However, as you know, summer evenings in Florida are pretty bad. We generally get a lot of cloud cover, and the chances of seeing it in the evening are a lot less than seeing it in the early morning. Now, if you want to see Neowise tonight, which, by the way, current forecast shows really good sky conditions tomorrow morning around 4 or 5 a.m. The comet actually rises about 5:07 tomorrow morning. So 5:30 is really the time that you really want to look for this comet. And what we're going to do is we're going to speed up time here to about 5:30. 5:30 is kind of where the sweet spot is for this comet. And we are past astronomical twilight, but it's still very dark outside. And what we're going to be looking for is the constellation of Auriga, the charioteer. So here we have Auriga, the pentagon shape here. We have the star Capella right here, a nice bright star. We also have this star called Menkalanum, and we have this star called Massim. There we go. It's a really, really hard word to say. Massim. And this star right here in the constellation of Auriga is kind of where the comet has been located, kind of in between these two stars right here. So you kind of want to find Capella, and then using a pair of binoculars is very helpful. Kind of point down towards this brighter star here, and then kind of look in this general area of the sky here. And you will start to see Neowise start to emerge and get higher and higher. So pretty much you have about 45 minutes of viewing. So really it starts to get harder and harder to see. You have about till 6 o'clock really to see the comet. But really the sweet spot is about 5:30 in the morning. That's kind of when you really want to get out there and start making your observations of the comet. And between 5:30 and 6 is kind of the sweet spot to observe this comet. So that's my next observing challenge for you this month, is to really either get up in the early morning or get up or stay up in the evening and see if you can observe this comet. The next time this comet's going to be viewable is the year 87035. So if you plan to live that long, you plan to live till the year 8000, you might be able to see it again. So this is a once in a lifetime experience, and so far from my personal experiences, it is pretty close, not as bright, but it was naked eye visible when I was able to see it. I'd use averted vision. I couldn't look at it directly, but using averted vision, around 5:45, I was able to observe neo-eyes. I was able to see the tail. But through a pair of binoculars, it is spectacular. You can see the coma. You can see a very nice tail. And, of course, if you're interested in astrophotography, this is a great photographic comet. So definitely get out there, make some observations, and enjoy this beautiful spectacle. 2020 has been a really rough year in many ways. And so I think it's time that the universe has treated us to something cool, and this is it right here. So get out there, do some observing, and enjoy a beautiful comet. And that's what I have. So again, just a quick recap of the observing challenges this month. We have M8, which is the Lagoon Nebula, M22, which is the Trifid Nebula, and of course, Comet Neo-Eyes. So happy stargazing, everybody, and good luck with the observing challenge. And I wanted to mention too, I'm going to go ahead and start, I'm going to share my desktop here. I wanted to bring up some of the photos. We had some observers last month. Len Ward has won the observing challenge of this month. He has made the most observations. And this is his sketch of Plato. So I think that's really, really well done, Len. And looks like his seeing was really good. Telescope was AR-102. And he was using a planetary camera. So, and this is his image of Plato. He also has taken some other images. Here's Patavius. And I like the fact, yeah, tomato, exactly. And again, very good seeing conditions, very good transparency, seeing it during a waxing crescent moon phase, getting that really nice termination. So great job on that, Len. And we have the Sombrero Galaxies. Remember, one of our observing challenges was M104, and this is from Bill Castro of his observation of M104. So great job, Len and Bill, for being our observers of the month. And again, we hope that you get a chance to get out and observe and be a future observer. So thank you much, everybody.
Yeah, great job, Lynn and Bill. Really great job. I really was going to sketch the craters, the moon things, while I was in Colorado. I was out there for 2 weeks and would have had plenty of time. I wanted to mention, in ancient times when astrology ruled the world, comets were actually a harbinger of doom. I'm just saying that. I'm just saying.
Well, it depends on what culture. Depends on what culture. Sorry, you're talking to a...
No. I don't trouble me with inconvenient facts. I selected the facts that backed my point of view. I very carefully selected the culture that supported my point of view so that I could be right. So you are entitled to your alternative facts if you want, but I don't want to. All right. I want to hear them. Very, very good. All right. That dangerously political for the Astronomy Club. We'll just stop there because that could go either way. It could definitely go either way. All right. So next up, our last program is Bill Castro is going to talk to us about his variable star observing. And I want to take this opportunity too, before Bill talks, to say or to invite other members. If you have a personal favorite thing that you are studying as an amateur astronomer, or an area of study within astronomy, and you would like to give a short presentation, don't think of it as a presentation. Think of it as sharing with people. When you talk to your family members about what it is you get excited about and they get all glazed over and they don't care, we do care. We think it's just as interesting as you do. So think of it as good mental therapy you can share with a bunch of people who are just as weird as you are in the eyes of your family members. And we would very much love to hear what our other club members are working on, in their own pursuits. And with that, I'm going to shut up again and let Bill talk. And take it away, Bill.
Yeah, I'm awake. Well, I guess you can hear me. Do you have the presentation, or you want me to pull it up on my screen?
Oh, it usually works better if you share it on your screen.
All right. Let me open it up and get that going.
It'd be great when you're giving your presentation, Bill, if you make a few mistakes and flub up on purpose. That way other people will feel comfortable and less intimidated to give their own presentations. So if you make any mistakes, we know you were doing that on purpose just so that the rest of us would feel more comfortable. And we appreciate that.
Great. That's the least I can do, and I want to do the least, right? Okay. So as most of you have heard in other variable star presentations to the club, variable stars are stars that vary in brightness over time. And those earlier presentations discussed CCD and photometry applications. So this talk will be on visual variable star observing. And by visual, I mean using your eyes as the sensor. And so it's really an easy thing to do. It can be added to any observing program. It only takes a couple of minutes per observation. You can do this in light polluted or moonlit skies with minimal to no equipment. And we'll talk about some basics on variable star observing, and we'll go through some AAVSO screenshots of where to get additional information. And there's always club members available to help. So I've got this slide in here for two reasons. One, I'm relatively new to the club, so here's a little bit of my background. I was transferred here from Ohio in 2014, and my wife was not very happy at having to move. She lived in Ohio her whole life and came down kicking and screaming. Fortunately, after 6 months here, she said, I understand why people move here, and she liked it. So now we are recently retired and we're staying here. The second reason for this slide is to note that I've got a wide variety of astronomy interest, and variable stars is just one of them. I'm an observer with the AAVSO, but you do not have to join as a member to do this. There's no cost to be an observer, but you do have to register with them. So the pictures shown here, up here is the Transit of Venus outreach program with my astronomy club in Ohio. That was a good bucket list outreach program with a lot of people in attendance, as you can see from there. In the lower right, you can see my 16-inch Dob there. You've probably seen that at Geneva Nights for Public and Deep Sky Observing with just club members. And then down here in the lower left, Stella Kafka is the AAVSO director and CEO. She presented to a CFAS meeting a couple of years ago, I think. And that got me going again on variable star observing when she said visual observations are still needed. What I find interesting in variables are that it's a cyclic patterns and they're fun to watch. So something's changing. Depending on the star, you can see something change over the course of hours, days, or months. It also sharpens my observing skills, so star clusters look better and I notice more detail in the eyepiece, not just open clusters, globular clusters, anything I look at through the eyepiece, I notice more detail. And the third thing is you can contribute something to science, and I'll go over that a little bit later. So This could, as I said before, this can be added to your observing or imaging programs. It only takes a couple of minutes per observation. You can do this in light polluted or moonlit skies. And typically I'll add a handful of variable stars to my observing list about once a week. And I should note that there are imagers out there who have another scope set up on the side for visual observing, and they'll include variable star observing while their main scope is imaging. So just saying, people, you can do this. So the equipment that I've used are highlighted here up in the upper left. You can just look up. Algol is a great variable star you can change during the course of an evening with your naked eye. Now, I don't recommend making estimates inside your full screen, but if that's all you got, hey, go for it. R, Leo, and Mira are stars you can observe with just some plain 10 by 50 binoculars. Those work. Now, another scope that I've used is, you see my 5-inch refractors down here, and that gives you a nice wide field of view, so you can see a lot of variable stars for comparisons. That makes it easier to make your estimates when you have that. This picture is from our Moon Week event at Seminole State College. That was a pretty well-attended event. Then the lower left, larger telescopes with GO2 are great for finding and seeing fainter variables. And there's my 11-inch scope at the Kennedy Space Center event, the outreach event that we had, and that was definitely the best outreach ever. Kudos who will ever set that one up, and hopefully we can do that again. That was great. So here's a screenshot of the AAVSO homepage, and just circled at the top, there's Getting Started pull-down tab. And then down there is Observing Tutorials, and then you click on the 10-star tutorial link right there. And that'll take you to this page. That's the 10-star training tutorial page. There, I said it. It's suited for binocular observing, and not shown on this screenshot here, but down below that, when you go to that page, there's a list of variables that are well suited for binoculars. Now here, and I should have circled it, but on this link here, under that 10-star training tutorial for Northern Hemisphere, click on the English version, and that'll pop up a Citizen Sky page. All right, that's the page there. It's a 16-page PDF document, and it discusses the basics of what variable stars are, light curves, how to read a star chart, how to make a measurement, how to submit estimates to the AAVSO if you so desire. You don't have to. You can just view these on your own for your own personal interest. It also lists a 10-star program for easy-to-observe stars, and that'll help you improve your skills. So stated here, there are too many variable stars for professional astronomers to monitor alone. So help is needed to monitor these over time. For many stars, visual is the only available record of behavioral patterns. Astronomers can use this case history in papers and in planning observing programs. Excuse me. The AAVSO also issues alerts to amateurs to monitor variable stars for changes in brightness. So this alerts astronomers to either look at, excuse me, or turn sensitive instruments away from the star. It can also coincide visual data submitted with other wavelengths of light. And so the visual observations are best suited for the brighter stars. That's the wheelhouse of doing visual observing. It's basically stars, magnitudes 12.5 and brighter. So step 2 here is to, if you go back to the home page, you can scroll down to the bottom of that. You get the site map, and that's what's shown here. And under observing here, just go down to the visual observing manual. You click on that, new window will open up, and in that window, you click on the AAVSO manual for visual observing of variable stars. It's a downloadable PDF. and it's the March 2013 edition. It's the only one you can download. And there it is. That's a 66-page PDF file. And it goes into details on telescope use, some web page screenshots for how to print maps, and how to submit observations. There's some additional information on the different types of variable stars as well. So it's always interesting to know details about the object you're looking at. You know, is it a pulsating variable like Betelgeuse, or is it a close binary system with a dwarf nova like SS Cygnus? And you know a little bit about what you're looking at. So here's an comparison star chart example, and the variable star name is at the top. In this case, it's SS Cygnus. This is a great star to start out with when you're using a telescope. And the coordinates are at the top. That's great if you have a go-to telescope. If you need a finder chart and you have to star hop to it, the AAVSO webpage will have some finder charts you can print out from there. Or I found that if you just type in the variable name and that abbreviation, CYG, for the constellation it's in, your planetarium software will have it in there if you do a search on it. You know, I know it works for the Sky Student Edition that I have. I have Stellarium, it's in those. And it's also in Sky Safari Plus. I imagine it's in several other ones as well. And so the variable star is in the center, that I'm pointing out there. It's in the crosshairs. Comparison stars are labeled without the decimal point. So, for example, this 11.9 is really 11.9. So they omit the decimal point so you don't confuse that decimal point with a star. Now I've plotted this one out with the left-right swapped, or east-west and swapped. So it looks like it would be in my refractor or Schmidt-Cassegrain with the star diagonal. So that's what you're going to see is what you get. You will have to rotate and orientate the chart to match the view you're seeing in the eyepiece, depending on if you're looking at that time north or west or south or whatever. You can also print these out as you would see it in a Newtonian or your naked eye, however you want that swapped or rotated. And from there, you measure the star by extrapolating between the two comparison stars. So say, for example, you know, this star, you look at it and it's brighter than the 12.3, it's dimmer than the 11.9, then you kind of look a little bit more at it, it's right in the middle. I would call it 11 or 12.1. So for the submitting the data, you would want to note the date, the time within a minute, the variable estimate, the two comp stars you used, in this case the 11.9 and 12.3, and the chart that you used. And the chart you used is, I've got that circled in the upper right corner, that's that alphanumeric character, so you want to note that. And that's what gets submitted to AAVSO. It's really that simple. So that's pretty much all I have for now. Most, if not all, the information you need is online at the link at the AAVSO webpage, the links we showed in this presentation. So feel free to contact me if you're interested and have any questions. It's been my experience in helping other people that any questions we've been able to answer over emails. So you can get a hold of me through the contact information listed here, either the group's IO page or just get a hold of me directly at my email. So
Thanks,
with
Bill.
that, how do I get out of this thing now?
There's a quick
There.
sharing. It looks like you figured it out. Very good.
Yeah, I have the power.
Ah.
Yeah. Oh,
Thank goodness.
all right. Derek saved you. I have a couple of questions for you. Well, one comment, actually, just, you know, one of the things you touched on was you really don't have to know anything to get into this.
That's why I got into it.
There's exercises and practice, and it'll basically take you from zero to master variable star observer with their program. one question is, do you still actively submit observations to AAVSO?
Yes, I do. I've got over 600. I'm still doing, a handful a week.
Yeah.
And that was great when we had when Stella Kafka presented to the club, I don't know, 2 or 3 years ago. I talked to her afterwards. Said, visual observations are still needed because we thought, you get the impression that CCD and photometry is what they really want. And she said, no. And a lot of the brighter stars are what they want, because they swamp out a lot of the sensors and other things. And so it's good stuff. And when I was working, you're working crazy hours and all that. I couldn't do a whole lot. But lately I've been doing more and more.
That's really cool. So we got Barbara Harris, who's really active, and she's doing camera-based photometry.
Right.
And you're doing visual. So CFAS's heritage is alive and well. That's really great to know that we've got members who are still very active doing that sort of thing. Okay, and thank you again for putting that together. And I hope that inspires someone else who's interested in whatever you're interested in astronomically, why you joined the club, to talk about. If you just want to talk about your love for Dobsonian telescopes, that's fine. You could put together a little short presentation and share your love for anything that has to do with astronomy. After all, that is why we're here, to educate each other, but also to share and offer emotional support for our passions in a world that's not always understanding of what it is that makes us tick. So we're on 2 hours now. I'd say we've had a pretty decent meeting tonight. One thing I've not been doing that I should have been doing in the past is sort of opening up the floor if there's anything any members want to contribute. We always did this in the planetarium at the beginning of the program, kind of an open mic segment. We're not going to go for half an hour or anything, but I do want to give any members an opportunity to speak up and say, hey, there's a great place to go look at the comet, or hey, did you hear about this great thing that's going on next week? So if anybody wants to speak up, raise your hand. I believe, Derek, anybody has the ability to unmute themselves. Is that correct? Or do we have them all on force mute?
No, it's just that they're muted when they come in, but they can unmute themselves.
So that's default. We mute you just so that we don't hear all of your cats meowing and dogs barking and refrigerators running and so forth. But if we don't have anything, then I'm just going to... Yeah.
I guess if people are interested in observing the comet, that's something I guess I could have mentioned when I did my observing report, is a couple of really good places to go observe it. If you're in the northern area of the Orlando area, Mullet Lake Park is a 24-hour park. That's a great place to view because it overlooks parts of Lake Harney and the St. Johns River Basin, so you get a nice clear horizon towards the eastern part of the sky. So that's a great place to go. Another place, if you're over kind of in North Orlando, is a little area called Hatbill Park. It's kind of on the way towards the Space Coast off of 46. That also is a great place to get a nice, good, clear view of the sky towards the east. If you're more towards the southern Orlando side, Hal Scott Preserve is a 24-hour park. You can park in the parking lot there, and that's also a great place to observe the comet, as well as Mauricio's go-to spot, the Seminole Preserve located near the Orlando Wetlands Park is another great area to observe the comet. If you're south of Orlando, another good spot is anywhere along 192 in Harmony, or down towards Bull Creek or Three Lakes. Any of that southern area heading towards Kissimmee Prairie is a really great spot. But really, honestly, you just need a clear horizon. But if you want to get away from light pollution, that's your chance of really getting a chance to see the comet naked eye. But and as far as the west side of Orlando, what's really nice about the west side of Orlando is that if you're in the hills like Claremont or those areas, you can actually get above most of the city, and actually you can get an interesting view that way too. So anywhere there's a nice clearing will be a good spot. So I don't know if Len, if you have any recommendations for spots to go on the western side of the Orlando area. I know that you you do some observing over there, but these are some places you can go. I don't know if Len's here. He might have dropped out. Yeah, he's not here.
I plan to get up at 5 in the morning. I'm going to go up to the duck pond between, in our neighborhood. So, yeah, there's quite a bit of horizon there. And northeast, that actually is pretty low. So I bet I can catch it there. So, all right. Well, good luck, everyone. Stay safe and keep looking up. And we will be having a meeting in August. We'll have an agenda for you, that we'll publish before the meeting. And I hope everyone has a great month and get some observing in. Turn in those observing challenge sketches or photographs if you can. And hopefully the weather gods will shine in our favor this month. So, and with that, goodbye.
Thanks, everyone.